Our task is to identify the majority element in an array. And of course, there are some arrays where there is a majority elements, but for the most case, there are no majority elements. So what are those majority elements? Well, those are the values which appears more than n/2 floor or integer, since it cannot be like a float times. Yeah, so integer value times in an array of length n. So more than half. Yeah, so more than half elements. If more than half elements are exactly the same, that means that we have a majority element. If such an element exists, return it, otherwise indicate that no majority exists, and we will just throw an exception. And in addition, like it's the same information, but restated maybe in clearer terms, for an array of length n, a majority must occupy more than half of the positions. Yeah? That means that at most one majority element can exist. Yeah? We cannot have 2 or 3 elements all taking more than half of space. That's impossible. And here are some examples. We have 2, 2, 2, 1, and 3. Yeah, so 2 appears 3 times. It is a majority and appears 3 out of 5 times. Yeah, then we have the second example, 7 4 times, appears 4 out of 4. It is a majority element, and in this case, we have no majority element. We have 1, 1, and 2, 2. Yeah, since each of them appears exactly half, but it has to be more than half, to be majority. And in this case, there is no majority element. And in the case of the single element in an array, then the single element appears like with takes all the space, and it's still a majority element. So we will do 2 approaches. One is majority counting using Boyer-Moore algorithm, which is quite famous and quite efficient. That's the first thing that we will do. And the second, using standard dictionaries or unordered maps, as they are called in C++. Yeah, so this is probably the second example is more like maybe not more clear, but easier to understand. But still, I think it's good to know that there are algorithms which can help with this problem and are quite fast. And then everything else below are just test functions or test helpers for tests and nothing else. We will have all those cases that we mentioned in the tests, and we will verify for all of our, or for both, not all, since we only do 2 implementations. For both of the implementations, we will call all those test cases. And now let's start with the Boyer-Moore algorithm, which first takes we can call it candidate. Yeah, it takes the first element of the array as the first candidate, and in addition, it keeps track of the count, which it starts not with 0 but with 1, and then we loop through each element. Number in our input array, and if the count ever goes to 0, then we change the candidate to the current number and reinitialize or reset the count to 1. Otherwise, we check if the candidate is the same as the current number. And so if candidate, if it equals current number, then we can increase the count by 1. Otherwise, we decrease the count by 1. And the idea here is that if there is a majority element, it will never go, the count should never go to 0 once we find such a candidate, since others will be, will have enough of other numbers which will always increase it and will never go to 0 or below. And then after this loop, we still have to check. That's why there is this helper function is majority, since it could be the case that we all the time were switching the candidates. It was going all the time to 0 and we were checking the new one. And the idea is that if there is a majority element, it will be in the candidate after we exit the loop. But it's not guaranteed, since of course there are a lot of arrays which have no majority element. So we have to check it. This majority, provide our vector and the candidate. And if it is majority, then we can return the candidate. Otherwise, we have to throw invalid argument. And now here we can do a count from algorithm. So return as count array begin on the iterators from the beginning of the array till the end. We will count how many times candidate occurs and is it bigger than array size over 2 and divided by 2. If it's bigger, that means that it is a majority, otherwise it's not. So let's save and try to compile this part. And we have some errors. Yeah, 63. That's true. I forgot to close. And 39 and 64. And let's go to the semicolon. And 64. Yeah, here as well. Let's recompile. And almost all the cases are correct except for the large random. So let's see what failed. So it looks like we are overcounting here, since we initialized the count to 0, but then we started again from the first element, which we have already counted here. So what we can do is just change from 1 to 0 here. And now let me recompile. And now we pass all the cases. And so let's now think about the dictionary or the map approach, where we create an std unordered map from int to int of our frequencies, and then we go through each element for const auto number in the input array. We can check, or no, we don't have to check anything. We just can increment the value which is stored under the key, which is our number. So the numbers will be from the input array will be the keys, and the frequencies will be the values, like this. And then here, if the frequency or the number ever exceeds the size divided by 2, so it takes more than half of space, then we return that number. Otherwise, we also have to throw invalid argument, since there is no such, there's no majority element. Now we can compile. No warnings, no errors. Let's see. And all the tests passed successfully.